A lambda expression is a function that doesn't have a name and that evaluates a single expression and then returns its value. So you can use lambdas in your LINQ queries to supply parameters to LINQ query methods that are functions themselves. So in this query, we want to bring back some information for beverages, and we want the product name, the number of times it's been ordered, and the total revenue. So we go into the products table and we bring back for each beverage the name and then the count of product.order_details. Product class has a property called order_details, which represents the detail records from orders for that product. So we bring back the count. Then we want to do a sum. So sum is a function or a method on order.details, and we want to pass to that a function, and that function is going to multiply quantity times unit price. So the syntax is product.order_details.sum, and then pass O, and then the equal greater than sign. That defines the function, which is then going to execute quantity times unit price. Extension methods extend existing types or an existing class. So here I want to know total revenue for product 7, but I want it in euros. So we first have a simple aggregate query. We're going to get from the order details table, details where the product ID is 7, and then we're going to multiply unit price times quantity, and then we're going to sum that. And at that point, we have a decimal value, but it's in dollars. We're then going to take that decimal value and convert it to euros. Now, decimal doesn't have a convert to euros method, but we can create an extension method on it and now use decimal.convert to euros and use that in our query. So let's go see some additional examples of using lambda expressions and extension methods in LINQ to SQL queries. And our first example is going to return revenue by beverage product. So our query is going to look in the products table and bring back products where product.category.category name is beverages. Then we want to bring back the product name, which we're going to call product name. We're going to bring back the count of the order details, so the number of times that product was ordered, and we'll call that number. Then we want to bring back the revenue. So we're going to call the sum method on order details, and we're going to pass in some instructions that we want quantity multiplied by unit price. So this will be a lambda expression. This right here is a lambda expression because we're passing essentially a function to a function. So we'll create this lambda expression, identify it as O, and then specify that we want quantity multiplied by unit price, and then that is going to get passed to the sum function, and that will give us the revenue for each product. And then we're going to display for each product the number of times it was ordered and the total revenue. Now if we go to the SQL Server Profiler, here's the select statement that gets sent. We want to bring back product name, count from order details for that product, and then select sum, quantity times unit price, and we'll call that revenue. And then we're going to do this for beverages, so we need a join on products and categories so that we can go get the category name of beverages. All right, our next example, we want the total number of orders for product 7. So our query says from detail in nwindatacontext.orderDetails, select detail, then I want the count of that. Now I could use a where clause in here from detail in order details where product ID equals 7, select detail.count, or I can pass my filter clause to the count method by using a lambda expression. So here my lambda expression is identified as D, and its product ID equals 7. And then that's going to tell me total number of orders for product 7. A very common usage of lambdas is when you want to retrieve a single record. So in all of our queries so far, we've brought back one or more records, or really 0 or more records. Bring me back all of the products in the beverages category. Bring me back all of the customers in the USA. But here I just want information on order 10530. And I know in the orders table there is one record for order ID 10530. So I can use the single method of orders to identify that I'm going to bring back one row, and then I can pass my filter or my where condition to that as a lambda. So this query says, go into the orders table and bring me back the single row where order ID is equal to 10530. And then display the order date, the required date, and the shipped date. And then if we go into the SQL profiler, bring back all of the order information from orders where order ID equals 10530. Now, what if there is no 10530? What if that order doesn't exist? Well, what will happen is I'll get an exception. So if there's a chance that nothing will come back, I really should wrap this in a try statement. So here I'm going to bring back order number 530, which does not exist, and trap for that invalid operation exception. And when it doesn't exist, I've handled that exception. Okay, let's look at extension methods. I want to get the value of orders for product 7 in both dollars and euros. So to get this in orders, it's pretty straightforward. My query is from order details where the product ID is 7. Bring me back the unit price times quantity and then sum that up. And that is the total value of orders for product 7 in dollars. There it is. Now I want to know it in euros. This first query returns a decimal. Unit price times quantity summed up brings back a decimal. And I could then take that decimal and convert it to euros, but what's actually easier is to create an extension method. And what I'm extending is the decimal type, and I want to add to it a method called convert to euros. So I have that in this class here, extension methods, the static class extension methods, and then I create convert to euros. I call it public static decimal. It takes an amount, which is a decimal, and then it returns an amount. And to make this an extension method, it's in a static class. It's a static method, and I use this. And then I'm going to return whatever you pass in dollars times 1.47, which at the time I wrote this was the current exchange rate. Now in a real live application, I'd go out and call a web service or something, but for our purposes here, hard coding it works just fine. So now I can call this extension method and include it as part of my query. And that will return the euros. Now if we go to SQL Server, SQL Server has no idea about extension methods. SQL Server has no idea about convert to euros. So what's sent to the SQL Server has got nothing to do with euros. We're going to get back from SQL Server the sum of quantity times price, and then this conversion to euros happens all on the client. The extension method is really just a convenient way of doing this all in the query, as opposed to doing it in the query and then doing the conversion. Grouping enables you to execute queries that group the elements of query results. And a typical use of grouping is when you want to use aggregate functions to provide summary information. So show me revenue by year. So I want to group order and order details by year and then do a sum to get the revenue. Or here's another example. I want to see all customers in Spain grouped by city. So my query says go into the customers table, bring back customers where the country is Spain, group the customer by city into a collection called grouped customers, and then the actual city I can get by grouped customers.key. And the key property refers to the grouped column. So city is the city, and then the grouped customers is the collection of customers. When we looked at querying related tables, I said that LINQ to SQL supports the join syntax, but we saw that it's much easier just to navigate through the object model. But you can use the join clause to relate tables and queries. And you could do that if you needed more control over the join, or if you felt it was easier to read. There are two types of joins. An inner join query will not include parent items without related children. So if I wanted to see orders by product, then if I used an inner join, I would not see products that had no orders placed. If I do a left outer join, then I see all of the parent items whether or not they have related children. So here's a simple join. I want to bring back products in the beverages category. So my query says from category in categories, join product in products on category ID equals category ID, and then where category name is beverages, bring back the product name and the unit price. So let's go see some additional examples of grouping and joining using LINQ to SQL. Let's look at some example of grouping, so I'll press G. And in our first example, we want to see customers in Spain grouped by city. So our query is going to be Spain customers, and go into the customers table, bring back customers where the country is Spain, group by city into a collection called grouped customers, and then bring back the city and the customers. So grouped customers is the collection of customers for each city. I want to know what the city is, so I can get that by the key property of grouped customers. Grouped customers.key is the city, since that's what I'm grouping on. And then grouped customers is a collection representing the customers in that city. Okay, so now we're going to have two loops. The outer loop is going to show me cities, and then the inner loop will show me the customers in that city. So now for each city, we're going to display the city and the number of customers. So for the first city, we'll display Barcelona 1 customer. Let's go into the SQL profiler and see what we've sent. We've actually now sent two queries. The first was to get cities from the customers table grouped by city. So this brings back the list of cities. And now we want to look for a particular city, which is Barcelona. So we're going to send this statement, bring back all of the customer information where the customer is in Spain and also in Barcelona. And then for each customer in that city, we'll display the company name and the address. Now we've already gotten this information for Barcelona, so all we need to do is fill out that information. Let's run to cursor here. Oh, I guess we ran through all of it. Go back into SQL Server. Here was the query to get customers in Barcelona. Here is the query to get the customers in Madrid. And then one last query to get the customers in Sevilla. So this query here, and then displaying the results, actually caused us to send 4 queries to the SQL Server. One to get the list of cities, and then one each for each city to get the list of customers. Okay, in our second example, we want to get a list of categories with more than 10 products, and we also want to see the products in those categories. So our query, hi product categories, from product in products, group the product by the category name, group by product.category.category name into the collection called grouped products, where grouped products.count is greater than 10. So only return for me categories where there are more than 10 products, and then bring back the category name and the actual products. So again, we'll do a query to get the list of products. That is here. Select category name from, we're joining products and categories where the count is greater than 10. And then let's do a query to get the products in the first category, which is beverages. And we'll display beverages has 12 products. Here they are: condiments, confections, and seafood. So for each of those, we send a query to get the products in each category. So a query to get the categories themselves, and then for each category, a query. This is called deferred loading, where we retrieve the categories first, and then we don't retrieve the items in the categories until we're ready to display them. In our third example, we want to get revenue by year. So we want revenue, and we want to group by year. Revenue is in the order details. The year is in the order. So our query says from detail and order details, and then we're going to group detail by detail.order.orderDate.value. Order date doesn't have a year property, but orderDate.value does, because the orderDate.value is actually of the type date time, and that has the year. So we're going to group by year into grouped orders, and then we're going to order by year descending. And again, we can get the year from groupedorders.key. Then we're going to return the year and the revenue, which is unit price times quantity. So here's the results of the query. Let's go into the profiler. We basically have one SQL statement. Bring me back the year and the revenue. Here's price times quantity, grouped by year, and here's the join on order details and order. So we really only need to do one group by query in this example. Let's look at some joins. So I'll press H. We've done this query before to bring back products in the beverages category. And in the past, we would have said var beverages from category and nwin data context.categories where product.category.category name equals beverages. But we can also do it using a join. Why would you ever use the join when you can just use the related tables? Well, you'd use a join if you wanted more control over the joining. Depending on the structure of your object model, the join might make it easier to read. So LINQ to SQL supports both. In this case, we'll use the join. So we want to get beverages from category and categories, join product in products on category ID equals, spelled out, not the equal sign here, on category ID equals category ID where category.category name equals beverages, and then just bring back the product name and the unit price. And then display the products. The SQL statement is a simple join. Select product name, price from categories, inner join products on category ID equals category ID. In our next example, we want to see customers in Spain and how many orders they've placed. It turns out there are 5 customers in Spain and 4 of them have placed orders. There are 2 ways to do a join. You can do an inner join and an outer join. First example is an inner join. So the query Spain customers, go into the customers table, bring back customers where the country is Spain, and then join orders on customers and group by company name. And I'm joining orders to customers, and actually can do the join in the more traditional way, or I can do the join using the object model. So I'm going to join orders and customers I'll join ORed in orders on cust equals ORed.customer because I know that the order class has a customer property. And I know that customer property represents the customer for that order. So I could join based on customer ID in the order table, the customer ID in the customer table. I can also join based on entities. Either way works. Then I'm going to group by company name and return the company name and the orders. Okay, so let's run this. And I see that there are 4 customers in Spain who have placed orders. There are 5 customers total in Spain, but one of them apparently hasn't placed an order. So when I do an inner join, I get back only parents with children. Let's go into the SQL profiler, and let's see how many queries there are. There should be 5. So the first query, customers in Spain. And then for each query, I bring back the orders for that customer. And I'm doing an inner join to group orders to customers, and that's why I'm only seeing 4 customers come back. Now in our next example, we want to do an outer join. Okay, so this time we're going to do an outer join and get all of the customers in Spain, whether or not they've placed orders. So the query says go into the customers table, bring back customers where the country is Spain, and then join ORed in orders on cust equals ORed.customer. And then put that into grouped orders, bring back the customer and the orders. So now we see 5 customers, including that one customer placed 0 orders. And if we look at the profiler, we're doing a left outer join to bring back the company and all of the order information for every customer, whether or not there is an order placed. So we only need to send one SQL statement, not a separate SQL statement for each customer. We just need the one SQL statement to bring back all of the company and order information at once for these customers. So let's once again look at the queries. Query number 1, using the inner join from cust in customers, join orders to customer. Here from cust in customers, join orders on customers. What's the difference? Well, the actual difference is the use of group. In the first query, we joined and then we grouped by company name into grouped orders. That does an inner join. If we leave out the group, we just join, then we're doing a left outer join. So it's a fairly subtle difference, but the difference is there. So again, we did the group. That creates an inner join. We leave out the group and just do a join. That's an outer join.